In this video, I'm going to show you how to build a web scraper that will scrape job data from Indeed.com based on the search criteria that you specify. If you're getting into web scraping, looking for a project to help improve your web scraping skills, then this video is for you. Before we get started, you'll need to make sure you have two libraries installed, BeautifulSoup and Requests. You may have these already, but if not, use pip install bs4 to install BeautifulSoup and pip install requests to install request. You can also use conda. Let's get started. I'm going to be using a Jupyter notebook to demonstrate this project, but feel free to use whatever IDE or code editor that you wish. The first step is to import the libraries that we're going to use for this project. CSV to export the data. We're going to use datetime to get the current date. We're going to use request to send a GET request to the server to get the raw HTML. And finally, we'll use BeautifulSoup to parse the HTML and to extract the data that we want from the job postings. Next, open up your browser and navigate to Indeed.com. Then, go ahead and enter a job title. I'm going to type in Senior Accountant, and I'm going to leave my local geography, Charlotte, North Carolina. The next thing to do is survey the page content and structure. Take a look at how the job data is organized and think about what data you want to extract from each job. There's job title, company, post date, a job summary, and some of these even have a salary range. The other things we'll need to figure out is how to page through all of the results. You can see that there's quite a few results here, and there are only about 15 per page. How would we replicate this same kind of search through a Python request? The key is to look at the URL. A lot of times the query that's being performed by the server is encoded in the URL. The question mark Q indicates the start of the query, and it corresponds to the what input box, which is why you can see the words Senior Accountant. The where input box corresponds to the L in the URL, which stands for location. I believe VJK is something that tracks your session or some kind of metadata about your search. I'm not positive exactly what it's used for, but I do know that you don't need it to send a GET request, so we're going to ignore it. You can also add additional search criteria, which you can see by clicking on the filters and seeing how they're formatted in the URL. However, we'll just use the standard query for this project. Go ahead and copy everything up to VJK, and we'll use this as a template to create our URL when performing searches via Python. Now, back to the code. Paste the text of the URL into your code as a string and assign it to a template variable. Next, delete the job text and replace it with curly braces. Then, delete the location and replace it with curly braces as well. This will create a string template that we can use to insert whatever job position or location that we want. Now, create a function called getURL with the arguments of position and location. Then, move the template variable inside this function. Next, starting with the template variable, use string formatting to pass in the position and the location and assign it to the variable URL. You don't need to worry about formatting the URL with a %20 or plus signs to fill in the spaces. The requests will interpret correctly without them on this website. However, you shouldn't include any punctuation or characters you wouldn't typically find in a URL. Finally, we'll return the URL. Use the new getURL function to assign the return value to a URL variable. And then I'm going to pass in Senior Accountant as the position and Charlotte, North Carolina as the location, without the comma. The next step is to send a GET request to the website and extract the raw HTML. To do this, use the GET function of the requests library, which returns a response object, passing in the URL we created as the argument. This will send a request to the site and the response will be sent back. If the request was successful, the response object will return a code of 200. You can also print the reason if you want to be more specific in the case that the request was not successful. Now that we have a valid response, we can extract the raw HTML from the response object with the text attribute. We can then parse this with BeautifulSoup to create a soup object. which we can use to navigate the HTML tree structure of this web page and extract the relevant parts. We'll use the default html.parser on this object, which is the second argument. Let's go back to the web page. What I want to do first is try to identify something unique about a job record that enables me to extract all of the job records as a collection. The best way to do this is to use the document inspector. So right-click on the item you want to inspect, such as this job card, and then click Inspect. On the right side or the lower side of the browser, you'll see the HTML content related to the elements that you clicked on. As you hover over the HTML tags in the code, you'll notice that the related elements are highlighted on the web page. And what I'm looking for is an HTML tag that encloses the entire record. If you look at what's being highlighted, it's easier to spot when you found it. Once we've identified the appropriate tag, we need to find a way to identify it uniquely amongst all other similar tags. For example, a div tag is pretty generic. There are lots of them. Often you can use a class name, an ID, or some other property to identify it. In this case, it appears that there's a class we can use called JobSearch-SERPJobCard. If we extract all div tags with this class, what we should end up with is a collection of objects that represent the job postings on this page. Now, back to the code. Starting with the soup object, use the findAll method to find all div tags that have a class name of JobSearch-SERPJobCard. This will return a list of all elements that meet this search criteria. If I print the count of these items, it seems to match the count of the items on the page that are job postings. Now, sometimes there are more items on the page itself, but these are typically sponsored content and they won't be captured, fortunately, by using this class. Now that we've identified the collection of records from the page, what we need to do now is prototype the extraction of the single record. And then after we've done this, we can apply the model to the entire record set. So let's get the first item in the card list and assign it to the card variable. Back to the web page. There are several pieces of information I'd like to capture here: the job title, the company name, the city, the salary range if it's available, the job summary, and finally the post date. I also want to capture the current date because most of these dates are going to be relative, so we need something to serve as a baseline. Let's start with the job title. Right-click on the job title and click Inspect. You may need to click Inspect a few times to get to the right level, or you can click the arrow to go down another level within the nested tags. The job title is clickable, so it's likely to be in an A tag. This means that we can get the URL to the job page also, as well as the job title. This one's actually pretty interesting. You can see clearly that the text of the element is here. However, if you look at the properties of this tag, you'll see there's a property called title that has a value which is identical to the text of the job title. This means that we don't have to worry about scraping the text of the element. We can simply grab the value of this title property. Because there are multiple A tags and links within this card, we need to be a bit more specific with our identification. So getting the H2 tag first and then the A tag will get us there. There's a few ways to go about this, but the most direct way is simply to navigate the tree structure using tag names. Starting with the card, we're going to use the dot notation and tag names to navigate the tree. Using dot notation, we'll grab the next element of its kind that you type, if it exists, and then we'll assign this to the A tag variable. I need to get the title property value, and to do this, I can access properties of these elements like I would a Python dictionary. So I can either index it like a dictionary with A and then title in the index brackets, or I can use the get method. Now, the get method is preferred because if the property doesn't exist, it will return none. But if I use the index method, it will stop with an attribute error, and this isn't what I want. The job URL is also within this A tag, and so this will be similar to the title, except that instead of getting the title property, we're going to get the href property. We also need to prepend the root to this to get the full URL address. The next item is the company name. Let's go back to the web page. Right-click on the company name and click Inspect. This one is located in a span with an embedded A tag. Fortunately, the span appears to be easily identifiable with the class name of company. So back to the code. Starting with the card, use the find method to find a span tag, and that span tag should have the class name of company. A quick side note here about the find and find all methods. These methods default to the property class as search criteria. However, I could just as well have passed in this search criteria as a dictionary where the key value pair represents the property value in the HTML code, and the value is the value of that property. In fact, this is exactly how we'll filter tags when we can't use the class as an identifier. To get the text value, we can use the text property, as you can see. If you find that there's extra white space around the text, you can use the strip method to remove that white space around the beginning and the end of the text. Next, let's find the job location. Go back to the web page, right-click on the location, and then click Inspect. Inside the div tag, you'll see the text for the city. However, if you look directly above this, interestingly, you'll see another empty div tag which has a property that contains the city and state. Now, we could take either path to get the city and state info, but the property appears to be cleaner because the text of this other field contains other text besides the city and state in some cases, which means you may have to do some post-scrape cleaning. So let's use the div which has a class of recJobLoc, and then extract the value of the property data-rc-loc. This will give us the cleanest version of the city and state. Now back to the code. Starting with the card, use the find method to find a div tag that has a class with the name recJobLoc. Then use the get method to retrieve the value of the data-rc-loc property. The next attribute to get is the job summary. Back to the web page. Right-click on the job summary and click Inspect. There's a div tag that serves as the container for all the elements inside this job summary. And even better, it has a class name of summary, so it'll be very easy to identify. Back to the code. Starting with the card, use the find method to find a div tag with the class name summary. Then use the text attribute to get all the text contained inside the element. Now, if you have some white space on the edges, you can use the strip method again to remove that. Also, some of these longer job summaries have internal line breaks, but you can replace those with spaces if you want with the replace method. Otherwise, you can leave it as is. Next, let's grab the post date. Back to the code. As usual, right-click on the element, then click Inspect. And it looks like we got lucky again. This one has a span tag with the class name of date. Back to the code. Starting with the card, use the find property to find a span tag with the class name date. Then you can use the text attribute to grab the text. As I mentioned before, we also want to grab the current date so that we have something to compare to the relative date that we get from the job posting. For this, we'll use the today function from the datetime library. This will return a datetime object, but we can format this as a string with the string format time method. The final item that we want to get is the salary range. This won't exist for every record, so we'll need to account for this with error handling. But let's take a look at the web page as before and dig into the element. This is a span tag that has a class that is conveniently named salary text. Back to the code. Starting with card, use the find property to find a span tag with the class name salary text. Then use the text attribute to grab the text. Now, if you try to use the text attribute when there's no text, an attribute error will occur. We can wrap this with a try except block that catches this error, and we'll set the salary to an empty string if it doesn't exist. Now that we've prototyped the extraction of a single record, we can generalize this code inside of a function so that we can apply it to all the records collected from the page. Create a function called getRecord, which will accept a single argument, card. Now what we're going to do is simply copy and paste the code that we've already written and paste it into this function. Finally, we're going to consolidate these items into a tuple and assign it to a record variable. Then return the record. Next, create a list called records. Then, iterate through each card, extracting the record from the card data, and then appending that extracted data to the records list. Feel free to check out a few of the items in the records list if you want to see what you were able to scrape. Now that we've generalized the model for a single page, we need to figure out how to get to the next page of results. So back to the web page. If you scroll down to the bottom of the page, you'll see a chevron button that, when clicked, will take you to the next page. Go ahead and click it a few times to see what happens. Well, one of the things that happens is that a start parameter is added to the URL, which you can see here. Now, this is one way to get to the next page. We could simply adjust the URL. But unfortunately, this doesn't behave as expected once you reach what should be the end of the results. I discovered this by trial and error, as is a common technique with web scraping. So we'll have to find something else. If you keep clicking the chevron to get to the next page, at some point the chevron disappears because there are no additional pages. This is the behavior we need to exploit to guide our pagination. So let's go back to the page that shows a chevron, then right-click and then inspect. As you can see, the chevron is in a list of buttons, and not surprisingly, it's an A tag. At first, it might not seem obvious how to identify this, but if you look closely, you'll see that it has a property called area-label with a value of next. So, with that information, we're ready to go back to the code. This element is actually within the body of the page, so unlike before where we started with a card, we're starting with the soup object. Starting with the soup object, we can use the find method to find an A tag that has a property of area-label and a value of next. We're then going to use the get method to extract the value of the href property, which will give us the URL of the next page. Now this serves two purposes. First, it's going to tell us where to go to next, but also it will be an indication that we've reached the end of the program if the find method can't find this tag on the page. If the program can't find the tag, it will return an attribute error because we're trying to pull an href property from an object that doesn't exist. This is a relative URL, so prepend the root of the web page to get the full URL. Next, we're going to create a while loop that continues to run until this URL block returns an attribute error, at which point we can break out of our loop. While we're in the loop, we're going to execute all of the code we've written up to this point. And with that, we've got everything we need to extract all the job data for our search. Now, what I'd like to do now is consolidate all of this code into a single block so that you can see it together. Then we'll add the code that saves the data to a CSV file. I'm going to copy and paste sections of the code that we've already built into this block. The final bit that we write is a main function that will accept two arguments, a job position and a location. Create the records list, then create the URL, passing in the position and location. Next, we'll run the loop we created above. The one exception is we're going to move that try except block where we find the URL to the end of the loop, because we're starting the program with a URL already. Finally, we're going to save the records to a CSV file. I'm going to use a generic name here, but feel free to customize this as you wish. You could add the current date to the end of the file name, for example. Now, run this main function, passing in a job title and location. Depending on the length of the search that you run, it could take some time. At some point it will finish and you'll end up with a very nice looking set of results in a CSV file. I hope you enjoyed this video. If so, make sure you click that like button and subscribe to see more content like this. See you in the next video.